Welcome to the second episode of Weaviate Air. We have a whole crew in here. I've got Zen, JP, Connor, and Erica, and myself, of course. And this episode is going to be super exciting. At least it is for us, and hopefully you find it as exciting on your side. And today it's all about the latest Weaviate release, but also we'll have something from Connor towards the end about like what's new in the AI, just like we did last week. And I think this is super exciting. So what we would like to do first is maybe a quick introduction from everybody on this stream, and I guess we can go in the order as we have it on the screen. Like so, Zen, you want to go first?
Sounds good to me. My name is Zan Hassan. I am a senior developer advocate here at Semi Technologies. I'm based out of snowy and cold Toronto, Canada. We're getting into that snowy weather hopefully soon. I enjoy it. A lot of people don't enjoy it, but it's a little bit about me. I'm an engineer, data scientist by training. Throwing it off to you, JP. Oh, this way.
Thanks, Zed. Yeah, my name's JP. I'm a technical curriculum developer at Summer. I've been here about a month now, and it's been really, really exciting. Obviously, it's my first podcast or live video session here, so I'm really excited to be a part of this. And yeah, I'll be kind of shaping a lot of the sort of educational journey for the audience who's come using Weaviate for various bits and pieces of their work. So I'm really excited to be on board for the journey.
Awesome. I'll go next. Hi, everyone. I'm Erica Cardenas. I'm a developer advocate here at Semi. I'm based out of Boston. I'm nervous for my first winter, but I'm also looking forward to it. And I'm excited for this episode. We're going to showcase a few cool things.
And hey, everyone. I'm Connor, also in Boston. As Zane mentioned with the weather, moved to Boston from Florida, and we're having our first snowy, cold season and missing Florida a little bit, but research scientist at Semi and been working on figuring out deep learning and search, and it's been so much fun.
Perfect. And I guess I'll go last. So hi, I'm Sebastian. I am the head of development here at Semi, leading this amazing team in front of you. And basically I'm all about like sharing everything that we are working on, and hopefully you all enjoy that. So what we're going to do today, let me give you a quick overview of the overall flow and the structure. So the idea is, and I already mentioned it a little bit, but the idea is like yesterday we had a release of Weaviate 1.16, and we thought that this is a great opportunity to pretty much share what we worked on, what went into that, but also like as a bit of a background. So as part of the whole release flow, the team here that you see here, each of us had like a different part of the new features or changes that we were involved with sharing. So we created this release blog post, and then we thought like, hey, like why not actually again go in Weaviate Air and then talk about the segments that we're writing about, and maybe like get into more of a conversation or maybe demo some of those features. So that's part number one. And then the second part, like I mentioned earlier, we'll have Connor who will go over the cool things that, like the cool papers that he was reading about in October. So Connor, I can't wait to learn more from you. And yeah, that's pretty much the general idea. Okay, so maybe instead of asking for volunteers, I'll volunteer myself to open with the first segment. So something that we did that was different around this release, or at least since V1.15, was we changed the approach in terms of how we are releasing patch releases. So in the past, we would be more like, we always had patch releases, like that's nothing new. But in the past, we used to kind of think like, okay, in order to release a patch release, we would say like, okay, let's get this and this and this fixed together. And once that was ready, then would kind of like cut that patch release and then push it. But then we realized that as much as this was very convenient for us to kind of do everything like, well, one patch go, or etc., we realized that people had to wait, or you had to wait basically for these fixes or feature improvements to arrive, right? So we kind of changed the focus, and the idea was to kind of like, let's go, and as soon as we have a fix, let's publish it, so that everybody in the community, everybody that uses Weaviate, have it available. And then incidentally enough, today, Erica, you can probably talk about it a little bit, but Erica you were working on a demo, right, for your later segment, and what happened?
Yes, I noticed it wasn't working. I couldn't perform the queries that is written in the documentation. I was kind of going a little crazy. I'm like, maybe it's an error on my side, but we found a small fix or a small error, and Dirk was able to help, and he submitted the first patch release of V16. So that's awesome.
Yeah. So there you go. Like, there was like a quick bug that we discovered. We should have discovered maybe a little bit earlier, but that happens sometimes. So there was like a specific edge case that was actually used in Erica's demo. But this was the really cool thing, right? Like, we talked to Dirk on the engineering side, and was able to like implement the fix. And we already are. Like, yesterday we published 1.16.0. Today we published 16.1, so that everyone can actually have a nice and working version of Weaviate, which is absolutely great. So yeah, that's basically it from my side in terms of my update. But I think since we already mentioned it from Erica, about Erica, then I think we can move to the next. And maybe one thing I should have done, probably, by the way, like, I'm such a rude person. It's like, thank you all for watching and taking time, because thanks, Connor, for pointing it out, because I think it's really important that you take the time to join us on this stream. And if you do have any questions, FYI, while we are running this is a live show. So feel free to ask any questions, and we'll try to answer them as we go as well. All right, so I'm going to pass it on to Erica. So Erica, what do you have for us?
All right, I will be covering the 2 new filter operators that are part of the V16 release. Would you mind sharing my screen? And I've created a demo for you guys. The first one is the is null, so you'll be able to see where the properties are missing or it was set to null. And then also you're able to filter by array length. So I will share a visual of this just because it's always better to demo things out. And then this is also how you find bugs. So a little bit like of a backstory, how I created this demo and kind of why I'm talking about food allergies is because we are all going to Italy soon. And Jesse, our wonderful head of people, asked, does anyone have allergies? I think maybe like 5 times. And I don't have any allergies, but I understand the importance of it, right? So Bill, Nancy, and Samantha are like a few people on the top. They do not work at Semi. I guess I should have used our real names. Sebastian thinks I see like dead people. Like I can just, I have imaginary friends. But
wait, so is Bill not in the company and Nancy?
Oh. No, I guess they're just in my imagination. So yeah, here we have a few people and their specific allergies. So for a few people, they have one, but then if we scroll down, we have Noah and Emma. So as you can see, for Noah, he is missing the property completely. But then for Emma, it is set to null. But it will import into Weaviate the exact same. So I just want to make a note, if you are importing a data set that is ginormous and you just don't have the time to go through data cleaning, this is a nice feature where you don't have to make you don't have to make sure that the property is set to null. It could just be completely missing, which is very nice. And then if we scroll down, we have George and Victoria, who are the ones who we need to give extra caution, right? Because they have more than one allergy. And we can see this in the console in a few minutes of how to take the array length and kind of see the people who have more than one allergy. All right, so this is a little bit about the data set and what we're going to be getting into in this demo. Quickly, I will go over to can you still see my screen? Okay.
We can see your VS Code, yes.
Let me just get that. Okay. How about my create schema? There's a little bit of a lag. Or you can see it? There you go. Okay. Sorry about that. All right, so here we have our schema, and everything is standard except with V16, if you want to index by the null state or also by the property length, you have to go into the inverted index config and set these two parameters to true. The default is false, but maybe if you anticipate your dataset having null values or that you want to filter by the property length, then just set it to true. It doesn't hurt you, right? So that's a little bit of the schema and how you have to configure that. Next, I will go over to the just click on it, uploading the data set or uploading the data to Weaviate. This is also standard, but I will just scroll down and highlight the key difference that you'll need in order to perform these filters. So you have to tell Weaviate that if there are null properties, that is okay, not to break, don't regurgitate like an error message. So yeah, just having the allergy.get, you're gonna grab the allergy, but if there's none, that is completely fine. And then also here in the properties where we've defined it in our schema in the last file. All right, so that's
Hey, Erica, I have a question. Because early on when you were showing the data, we had like two different kind of examples, I think, where, yeah, Noah doesn't have allergy, but Emma does, but it's set to null. How will we respond to that? What's going to happen to that when it imports it into the database?
Oh, well, good question. The short answer is that it will import the same, but in a little more detail. Weaviate imports the objects and it skips the null values. But then for the index, it will set the missing / null properties to null. It's kind of like back and forth. So it kind of does it the same. But do you want to jump?
Cool. So it basically doesn't matter whether we just skip the property or set it to null, right?
Exactly. Which is nice,
cool.
you know? Yeah. It's a good feature to have, and because I don't know, if you have a large data set and you can't really go through it all, it's convenient.
Nice.
All right. So let's jump into the console. Does that sound good?
Yeah, let's do it. I'm curious to see what kind of queries you can build.
Yeah. All right. So since I started off with the is null property, let me start off with that. So here we're going to get the food allergies, which is our class. And here I describe the name just so we can see that our data has been properly uploaded. Let's do the fun part of grabbing the where filter of the is null. Where? So, and this is not like this. All right. And now we're going to take the path of the allergy, right? Because that's just where we have the missing properties, and then we have the value boolean. So this, you're going to set it to true, and then we can also see that if you want to set it to false. And then we obviously have our new operator of the is null, and this should work. All right.
The moment of truth.
Everyone hold your breath. So yeah, here we're taking the allergy property and setting it to if the property is missing. Yeah, it's just going to return the names where it is missing. And then the alternative is to set it to false to find the people who do have the allergy located.
Okay, cool. That's by the way, I'm impressed how you can write your GraphQL under pressure, all live and everything. So that's pretty impressive, but that's really cool. So I guess at least my takeaway from it is that like we could use it to like maybe find people that do or don't have allergies, but maybe we could also use it to like clean up our data, right? Like say if we're missing like email fields, and then you could kind of go like, hey, let's make sure everybody in our database has emails. So we could like very quickly just find like, hey, I said null is fine to the database, but maybe not for the cleanliness of my database, right?
Of course. And in Jesse's case, this would be useful just to confirm that everyone won't have a food allergy or need an EpiPen in Italy, right? So it's different ways.
Well, usually if you do have an allergy, like you would be cautious and be prepared for all possible cases, right?
Of course. And then now for the people that might have a little bit of extra caution and we need to find, just people who have more than one allergy. It's a little more severe. We're going to we can measure the length.
Hey, could we also show the actual allergy property? Because I think you're just showing name for now.
Oh yeah, of course. Let me go back. And just include it down here. Right, because if the value boolean is set to false, then you'll be able to see Ava has a peanut allergy along with Samantha. And then for people that have more than one, it is also listed. And then, yeah. Good.
So let me guess, you'll be able to look for those that have more than one.
Oh, how did you know?
I don't know.
All right, and then I can. All right, so we want to find people who have more than one. And then set the operator to greater than. Now we have Victoria and George who need a little more cautious, like care, to make sure that they don't eat these specific things. But it's extremely easy, and that's the whole point of it, right? Is to show.
That's actually pretty cool. How quickly we can just find that.
Yeah, and it's nice. Yeah.
This is super
That's
awesome.
A little bit.
I have a question. So if we go back to the VS Code, how do I enable this functionality? Do I just have to, when I set my architecture, I have to let it know that I want this enabled?
Of course, yeah. So the default is for it to be false. But if you anticipate that there will be null values, or you want to index it by the property length, you want to set it to true. Just make sure you do that in the beginning, because if not, you'll run into errors.
Okay, awesome.
I had another thing I was thinking earlier in our meeting. We were talking about using k nearest neighbor classification Weaviate, and I was thinking, watching the is null value, maybe we could use the search with the unstructured data to fill in the missing values, because I think a lot of times we like fill in the median, but we can use this nearest neighbor thing to fill in the missing values. It's really cool.
Yeah, that's super awesome. You can do like k nearest neighbors imputation with this, right? Look for null values and then look for that's it. That's actually you'll hear more about that in the next Weaviate podcast, huh, Sebastian?
Exactly. Let's do that. You already signed up for it, right?
Yeah.
So got your name all over it.
Yeah, no, I agree. It's good for data preprocessing if you just want to go straight into using Weaviate rather than using pandas or Python. So it's nice to have this option.
Is there a way we could actually mix those queries, like mixing length and is null? Like, I don't know, we could maybe look for like, hey, show me the results where there are some allergies, but there's less than something. I don't know.
Of course. I anticipated that you were going to ask this question, so I'm going to copy and paste it because it's a lengthy one. I think everyone wants to see me type this.
I think we meet way too often because you can read my mind.
So just quickly, this is for people that have, oh no, it didn't even work. Why?
Maybe you're missing a closing bracket again at the end. At least through indentation seems.
There we go.
Hey.
Thank you. Good catch.
And so now that's how everybody knows that this is a live demo and not a fake.
Yeah. So just people who have less than 2 allergies, and then also their property isn't set to null. So there is a way to combine 2 operators. So, and that is my demo. Thank you so much.
Hey, and then documentation. Where in the docs can we find it? Do you have a link to us for us?
Let me drag this over. So if you go to GraphQL references, filters, if you scroll up, here's documentation on filtering by property length, and then also the is null filter. And then there is a disclaimer that you do need to set your schema to handle this. And this is where you will find that information.
Perfect. Thank you.
Awesome. Thank you.
Excellent. So this was great. So maybe how about we go next with Zen? Because Zen, you were covering a couple of features in the release blog post, but I'm pretty sure everyone would want to hear first about the Node Status API. What's all that about? Like, why do we need it?
Yeah, so this is a really interesting feature. It's a convenient feature, really, is what it is. It allows you to, once you've got your cluster spun up, you want to get an idea of how it's going. You want to diagnose if there's problems. This is you can submit a GET request to this API endpoint, and it tells you exactly how your data is stored on your clusters and whether there's a problem with your clusters or not. And if there is a problem, it'll tell you where the problem is. rather than me talk about it, let me show you a demo. What I'll do is I'll spin up a bunch of a Weaviate cluster with multiple nodes, and then we'll try to see if we can break something. All right, so let's do. So there's a bunch of terminals that you're seeing here. I'll let you know exactly. This is the most important terminal here on the right. I'm going to create nodes in these two terminals on the left. Right? So what I'm going to do is I'm going to set up Weaviate, and I'm going to start it up in this cluster. So let me kick that off. Okay, so now there is, I'm going to allow that. Okay, so now in my local host under port 8080, I've got one node for Weaviate up and running, and then I'm going to kick off another node here from the second terminal, and this is going to occupy port 8081. Kick that off, allow that, and okay.
So many nodes.
Yeah, we're good to go. And this is only 2 nodes. So now what I want to do is, let me make sure I'm in the right repository. I am. Okay, let me clear that. Now what I want to do is I want to run a run this import file that is going to basically send objects to these nodes. And so I upload data to these, and you can see that the nodes are responding. They're gobbling up that data. Okay, so we're good to go here. Now what we can do is, if we want to know if these nodes are perfectly fine, if they're communicating well together, we can go ahead and call this new API, and this is the main feature that we're showing off. Right? We can send a GET request to our local host here, port 8080. That's where the head node is, v1, and the endpoint is nodes. I'm going to take that, and so this is what the response looks like. It's a bit hard to see, so what I'm going to do is I'm going to pipe that to my JSON prettifier, and so now we can see that. Well, first of all, you see that this the nodes get the request over here, and you can see exactly the configuration that your nodes are in. It tells you how many nodes you have. So you have one node, and then you have the second node over here. You can also see how the data is stored in your nodes, what the object count is for each one of the classes that you've got here. And the classes here are pretty generic, so it's I'm not going to go into how the schema looks or anything like that. But the main idea here is the status of the node, right? So you can tell that node 1 is healthy, and node 2 is also healthy. Right? So there's 3 values that this status flag can take. Healthy is what you want to see, but now I want to show you what else will happen. Right? So let's say we simulate a crash in the second node here. So I just crash this node.
And for everyone at home, don't try to do it at home. It can be dangerous. Only let it to pros like Zen to do it.
Yeah, simulating a data loss event over here. Okay, so now we're shutting down this server, and you can see that the first node realized that it failed. It sent a ping to node 2. It failed. It's marking it as failed. Okay? So node 1 knows that the second node failed, but do you know that the second node failed? Right? Well, now the answer is that you can know. Right? You can call this API, same endpoint, and now you get another response, which is different from the response that we just got. And now it tells you that you have node 1, and you can see here that the status is unhealthy because you no longer have node 2. Right? And if you look into it further, you can see that because your classes you had object counts that were being shared and stored on node 2 and node 1, all of the object counts on node 2 are no longer there. Right? So you've pretty much, if this node loss was permanent, you've lost that data, right? And now you can tell whether your cluster is in a healthy or an unhealthy state. There is also a intermediate step here where, let's say you call this API in the moment that the second node is going down, you'll get a status update that says unavailable, and so that is a transitionary state between healthy and unhealthy. But I like to think of this feature as the cluster doctor, right? You're basically taking your stethoscope and you're assessing whether or not your clusters are in good health.
But okay, but isn't like when it goes down completely, isn't it unavailable actually?
Yeah, so that's interesting. So the technology that we're using behind this, once the node is completely down, it doesn't actually send any response, right? So we can't tell what the object count on that node was. So here you only get node 1, and the state of node 1 is unhealthy, not because node 1 crashed, but because the cluster had node 1 and node 2, and now node 2 crashes, right? So the status here is the status of your overall cluster.
Oh, right. That makes a lot of sense.
Yeah.
Okay, that's pretty cool. Hey, what was the command? And I'm gonna change subject slightly, but what was the command that you use for prettifying your JSON?
Oh, this is just JQ. So this is the so I'm piping the output into this JSON
Cool.
prettifier.
Because I always use JSON PP, so that's kind of interesting
Okay.
to see. Nice. That's pretty cool. I wonder, like, what will be probably cool to see next as well is like being able to subscribe to any of those events. I'm pretty sure Etienne has some ideas around it, or someone.
Yeah, I think it's pretty interesting. So right now this is just a more of a passive monitoring. So the doctor can see what's going on. They can't do anything about it, or they can't fix it at this point. The engineering team has some pretty interesting ideas on next steps for this to make this an active API where you can actually modify the state of your cluster through a similar API. So soon about that in an episode of Weaviate Air.
That's really cool. And also, I guess that'll be cool if there was a way to, I don't know, back up data from multiple nodes, let's say. Don't know.
Oh,
stay tuned.
We're getting to that.
Yeah, stay tuned for another 15 minutes.
And what happens if you want to rerun this? Will there be an error?
No, so you can run this API as many times as you want. Right?
How about if you fix node 2 so that node 1 would be healthy?
Oh, yeah. Yeah, so if we fix node 2 here, so if I rerun it, let's see. Oh, it doesn't run. It's telling me that the port is not available. It should be available. Oh, it's permanently lost. We can't run it again.
And kids, this is why you shouldn't be trying that at home.
You shouldn't be crashing your nodes voluntarily. Yeah. It's for science, guys. It's for science.
Awesome.
Love it. All right, thanks Zen. This was a really cool overview. So for anyone that's using clustered distribution for Weaviate, definitely you should know about this new endpoint, the V1 nodes. All right, the next person that we have is Connor. So Connor, you've been working on this. This is actually pretty personal release because not only you were covering in the blog post, but you were working on the Centroid module yourself, right, for quite a few months, and we spent some time working on the demo and everything. Tell us what's this all about?
Yeah, and thanks to everyone who's been helping me, in the creation of this, learn how new features are developed in Weaviate, and the research to product flow has been so interesting. So ref2vec, it's named as such because it's reference to vector. We have cross references between classes. And I think this is this relational structure that Weaviate adds in addition to vector search. As you vectorize unstructured data, you have structured symbolic properties that you can use to filter the HNSW search. And we have our inverted indexes of the categories. There's all sorts of things we can do with the properties. And I think expanding into what we can do with the relations is an incredibly interesting direction for Weaviate. So I'm going to start off by showing this example of ref2vec's application and recommendation. And then from there, kind of expand on the future of how we can do this. And then I think that also transitions well into the topic of using ref2vec to represent long documents that are longer than the, say, 512 token input length to sentence transformers, or or complex objects that say it's a real estate listing and it's got images of the houses, it's got graph structure data about the neighborhood, it's got the symbolic metadata, it's got text descriptions. So how can we have references in our data and then combine these vectors to represent massive things? So let's start with recommendation. So what we're seeing now, we're probably all used to using Weaviate to, search through our catalog. We say, search green shorts, and then bang, there are the green shorts. And we're used to doing this kind of thing. So we usually would have it as a products, it is our class as product, and then it'd say have text description. And so all the text descriptions of these items are vectorized, the query is vectorized, and then boom, approximate nearest neighbor, here's your product that matches your query. So now what we're doing is we're introducing a user class. So user class, liked item, item. So what we're seeing with this image grid is an example of having, say, a home feed, or if you want to have, like a home feed kind of feature into your apps that you can build with Weaviate now. So if you have a blog, you could personalize some kind of recommended articles with this kind of interface by using the centroid from the user. So now let's start using it. So I'm the user. I'm here. I'm looking for a backpack. I'm not looking for any of these clothing. So as you have the first backpack, you see how you're now doing a nearest image search where this backpack is the query. And say you're particularly looking for the strap backpack compared to like this duffel backpack. So you click another strap, and then it starts to, it will average these two vectors to be the vector that you're searching through these with. And so that represents the user preference of backpacks. So we could, have our home feed is loaded by showing backpacks because that's the only item that our user is interested in on our, say, e-commerce website. So another fun example of this, I think, is looking through the watches is just an example of something has like a particular difference. So you see with the watches how you could have like a digital LED screen, or you could have the, the classic kind of clock style. So as we do this, we see we have the digital screen. If we click two of them, it can visually tell to prioritize, see how these are ranked ahead of these ones. Similarly, if we click this style, unclick that style, and add that one, then it shows us this one also with the same style. So it's showing the semantic visual features that the pre-trained ResNet in the Weaviate image to vec module can capture. I think it's a really fun example. So it's kind of transitioning a bit. So right now it's called ref to vec centroid. We're averaging out these two vectors to form the vector to represent the user. Another interesting idea that we're exploring is ref to vec centroids, where we say have watches, backpacks, and we have these two clusters in our vector space. So we would have a centroid for each of the clusters. And so looking into whether we want to, say, use k-means or HDB scan clustering for this kind of thing. And a new Weaviate podcast is coming out is with Martin Grudendorst, who developed BERT Topic. And he explained so many interesting insights about the difference between k-means and HDB scan clustering and how they preserve the semantics in the centroid. So we're looking into that kind of HDB scan implementation in Golang and delivering multiple centroids, so you could have a blend between watches and then a blend between backpacks or whatever it is that you're recommending for the user. So then let's talk about this idea of how we're aggregating vectors across the edges. And this transitions into just one of the most interesting topics in deep learning, which is graph neural networks. So graph neural networks, message passing networks, you only send messages in each layer of the deep neural network to the neighbors. So you collect the neighbors, then you have several layers of doing this with nonlinear activation, differentiable weight matrix, until you do something like predict clicks at the end. So to contrast it with the graph neural networks, one thing we could do is have like an XGBoost machine learning algorithm where you would search for these watches, and then you would have a classifier that's trained on clicks to re-rank it based on the XGBoost classifier of whether you click this. But another thing we could do is propagate these embeddings out with graph neural networks that do that node classification task. And I think that's really interesting. So then concluding, again, we have this idea of, if you look at the Weaviate Wikipedia demo, we have a breakdown of Wikipedia articles are too long to put into BERT. It's longer than 512 tokens. You can't just have a BERT inference vector for the entire Wikipedia article. So it's broken down into passage, in article, and that's a graph relation with the passages. So the question is, how do we aggregate these vectors into single searchable vectors, or say we have this centroid idea? So the centroid idea would give us multiple vectors for the article to search through. So if we have the LeBron James Wikipedia article, we'd have centroids that say describe his career with the Lakers, Cavaliers, Akron, Ohio. These would be different centroid clusters. But maybe with the graph neural networks, we could compress that into a single vector. So I think there are just so many interesting ideas we can do, adding this relational structure into our vector search and these kind of cool ideas. So I think starting out with the recommendation, developing home feeds with Weaviate is, I think, one of the most interesting ways to get started using Ref2Vec.
This is cool because I was immediately thinking like this could be like a really interesting way to like provide recommendation if somebody, let's say you're doing research on a topic and then you're scouring like a huge database of papers, and then if you saw like one paper on on one topic and then something else, and then immediately could go like, oh, you look at two of those papers, let's say I don't know, graph connections, etc. You go like, hey, here's another few. And then based on what you selected, like continuously could provide you like more and more refined recommendations so that you can kind of keep going and keep looking for different articles. And if at one point you pivot into certain area, like the average can keep moving, right?
Yeah, I love that you said that. When we first wanted to explore this, there's this Twitter account called AK, it would be like 4201, and he tweets new archive papers every night, like 6 every night. It's crazy. And so, I interacted with this a lot. And so we extracted all the people who like tweets from AK, and then we put all the AK and then we ranked them based on doing this Ref2Vec. And I was able to see the difference and say my recommendations compared to, I did the user dissimilarity because I can use myself as a query. I can also find my most least similar neighbors, the most least similar. And so, it was someone who likes these audio papers. Like, it's not that I have anything against audio, it's just that I've never looked into it. And I just thought it was so cool to see it capture that in kind of a real world example, like exactly as you described.
Nice. Yeah, because like also like one of the things that I was thinking about is just like when I watch stuff on like Netflix or HBO, etc. Right, like they always give you like those recommendations based on like what you've been watching recently. So that sounds like something also that could work. But like, how far can we go back in with those searches? Like, is there like a recommendation, like go for up to 5, or can we go with 100? What's the story around that? I'm kind of curious.
Yeah, that's another really interesting idea we're looking into, is in the module configuration, having an interaction window. So say it only uses the last 3 interactions on the website to form the centroid. As right now, it's the averaging in a single centroid. So yeah, we could have that interaction window. And I think maybe another phrase I left out is just session-based recommendation, online recommendation. How you could open up, say, TikTok, and you don't have an account, and you just start interacting, and boom, already you're getting recommendations. You don't need to have train this machine learning model on click prediction. You can just boom, start running with recommendations.
Nice.
So I think this is pretty interesting. This seems like a game changer for both content-based and collaborative-based recommender systems, right? Is this more efficient than what is currently used in those fields, or because if from what I know of the field right now, they're essentially trying to capture the meaning behind the content that's consumed, right? If I buy one type of watch, then they'll recommend similar types of watches. Maybe they'll recommend the same company's watches. But what you're doing here is you're learning what's similar about those watches and then recommending it, right? So it goes one level deeper, right?
Oh yeah, that's a good point, because I always hate when like I search for something like, oh yeah, I don't know, a new tripod for my camera, and then like every ad everywhere else it kind of goes like, you've been looking for this. I was like, yeah, I know, that's not much help. But if you gave me a recommendation, like, oh, that's a cool tripod, I didn't know it existed, but yes, I am looking for a cool tripod.
It really solves the cold start problem, like along with new users, if they're most similar to some users' patterns before. And even for this example, when you clicked on the silver watch, that's a little more fancy. The backpack with the straps changed to this nice duffel bag, right? So you can kind of like put a whole outfit together with just like kind of searching around for what you want. So it's kind of cool.
Yeah,
that's
kind of cool that the duffel bag goes well with the silver watch.
It matches.
Yeah, that's super interesting, because now that you can break down a product into its individual components on a vector, there's nothing that's stopping you from comparing a fancy watch to a fancy backpack. Whereas before you were just like, maybe you're comparing like the relative price of that watch versus the relative price of the backpack. Yeah, I never thought about it that way. That's super interesting, actually. Yeah.
I guess the cool thing is that it's like there's so many ideas that even we didn't think about, and so I'm really curious how everyone else starts using it, and like what kind of use cases we're going to learn about. That's a call to action. Everyone, if you're watching it, you should definitely try Centroid. Like, try to come up with a use case that we didn't think about, and then surprise us and surprise Connor most of all, because he's so proud of his baby.
Cool.
Nice. Is that all, Connor? That covers the Centroids?
Yeah, I'd say we're also going to have a blog post published soon, and we're working interaction window, the UX for the collaborative filtering, as Zane mentioned quickly, where you have the rating thing, and yeah, just rolling along with this. I think recommendation is going to be such a cool use case for Weaviate, as well as because it is kind of search and personalized search. Yeah.
Perfect. Thanks a lot for this demo. All right, so I guess we have a couple of other features that we've added to Weaviate. And on my agenda, I have JP to go next. So JP, what are you going to tell us about?
Sounds good. Thanks, Sebastian. Could you pull my slides up if you don't mind?
I don't mind at all. Where
Fabulous.
are you? Here.
So I'll be talking about, it's going to be a little bit of a change of pace. So with 1.16, we've added Azure support to the way we do authentication with OIDC. Let's talk a little bit about OIDC though, because like I was writing the blog about it and I was like reading and I was like, oh, this is really cool. And I was thinking about what kind of like is the catchphrase or like the, byline I want to go with. And I was like, well, let's talk about how much we all hate passwords, because I don't know about you guys, but I use a password manager and trying to, maintain security practices and whatnot. But it is pretty unwieldy. And more and more.
Hey, JP, sorry to interrupt. But it's like, how is that even a question? Like, if you're not if you're not using a password manager, what's wrong with you?
Listen, some people don't. You'd be surprised. Working
I'm
in
kidding.
IT or in tech, it's a bit different. But yeah.
I promise I'm a nice person. But yeah, like if you don't, like I think it's a good idea to use one. But yeah, like it is a problem. Until we had password managers, that was such a huge headache.
Oh,
I guess that's not the only problem.
Yeah. People are like, oh, I've got a system. What is it? Oh, it's my dog's name plus like 4 different numbers. And it's like, no, that's not a good practice.
I can change my passwords now.
So it wasn't meant to be a subtweet, Connor, but so we'll talk a little bit about OIDC. So it's really cool. So more and more we're seeing like these single sign-ons, right? Whether it's through Google, through Microsoft, or whatever. And it really tackles this one problem of like, how do we secure our resources and maintain usability? And I was really, excited to see that we've at Weaviate or at Semi included OIDC features, so it can do authentication easily whilst maintaining security, right? So that's kind of what my next slide is. It's really a combination of the two things that give you those features. It's authentication that tells the end client or the app who you are, and you can trust who people say who it is. And based on that, you can do your authorization, whichever way you want to. So some people obviously do both in the same, using the same tools, I suppose. So authentication with OIDC and maybe your authorization with OAuth. But with Weaviate, we use OIDC for authentication, so we can trust that people are who they say they are, not just a text box typed into a field. So I can pretend to be, I don't know, Elon Musk or whomever. And based on that, we can use that identity to enable differentiated authorization. And for people who's not really familiar with how OIDC works, this is kind of the workflow. I've skipped a couple of steps. But basically the point is that, in the same way that a lot of people would have seen, you go to log in somewhere, whether it's, again, Microsoft or whatever, and then you sign on and you get a token back. And of course, through the magic of public private key security, you know that your token is secure. And we pass that token to Weaviate, and Weaviate's like, oh yeah, you are, this person, Connor at semi.whatever, or you're not, right? Because your token doesn't have the right signature on it. And you can send them the right response. So the change with 1.16 is that we've added Azure support. So even though OIDC is an open protocol, people do implement it slightly differently. So that means it's not like a one-size-fits-all solution. Luckily, we're using the module system, which means that we can keep on adding these functionalities as we go. And one of the benefits, of course, with Azure is that a lot of people would already have some sort of a employee directory or some sort of directory of users in Microsoft Azure Active Directory. So we can leverage that, or they can leverage that with Weaviate. So if you already have a database of users, you can use that, get people to sign on through there, get their identity tokens, and go and do your thing in Weaviate. So as an example of what that allows you to do is to have one database where you can give tiered access to different people, right? So instead of having like, oh, here's like one instance of Weaviate, which is for like public access, here's like one instance of Weaviate for like actually private use, whatever. What we can do is to control who gets access to what. So you might say, well, actually, everybody, regardless of who you are, whether you're authenticated, even if you're like an anonymous user, you can read some part of your database, right? So maybe your demo data set, as a lot of data providers, tend to do for marketing reasons, or just, just getting your name out there. But then with these tokens, you can give one group of users read access to the whole database as long as they're authenticated. And you can have another list, and this is where the authorization based on your authentication comes in. So you can say, well, actually, these guys are in the admin list, so they can actually read and write, whether it's deleting certain entities or entries and adding new objects, right? So you can do all of that, and really having these OIDC tokens means we can decouple the security requirements, because that's kind of not what we do, right? And people can trust that these things are happening securely. You don't have to remember yet another bloody password, and it's all kind of done securely and safely while kind of not compromising on the accessibility side of things. So yeah, I kind of learned a lot reading about it and writing about it. It was really cool. And yeah, it's good that I think, all these authentication and authorization needs are moving to these kind of open, transparent and secure standards that are evolving, as well as, easy to use. So yeah, it's really cool.
Hey, so because you talked about OIDC, but like I also know about OAuth. Like, what's the difference? Like, how do they compare?
Yeah, that's a good question. So they're both by the same standard OpenID. Standard OIDC is built on OAuth on top of that. So the main difference is that there are two different types of tokens, right? So you can get the what's called an authorization token. I'm going to have to make sure I don't mess this up. Authorization token, which is typically used for providing access to certain assets, right, based on things. But OIDC is built on top of that, so they provide. But authorization tokens doesn't tell you anything about who it is. It just says whoever has this token can use these resources. Whereas Open OIDC adds on top of that and adds what's called ID tokens, right? And the ID token will basically have secure encrypted information about, or signed, I should say, information about who you are, right? So it'll say this person, whoever is using this token, is this person, and we can kind of we use encryption to prove that is true, right? So that's the difference.
I see.
And how are the tokens validated?
Yeah, so it's like the asymmetrical, basically like it's all the magic of asymmetrical encryption, right? So it's a public private key encryption, the same way that if you log on to GitHub using your keys, you have your private keys, and GitHub has your public key, so they can see that your information is encrypted and they can decrypt it, even though they can't encrypt it themselves, right? They can tell that it has been encrypted by you. And the signature kind of works the other way, where the signature is signed by let's say Microsoft in this case, by Azure, because they've got their private keys. And if you have their public key, you can verify that it has been encrypted by them and has not been tampered with. So yeah, I don't want to pretend to go too much into the maths, but it's all one-way functions with very large prime numbers and all that. So
I did take one course in cybersecurity, so it sounds familiar.
But yeah, just as a huge nerd, I remember reading this book called Crypto back in the day. It's just like way off topic, but it's all about like the development of RSA standards and like who did it and all these like interesting stuff about like export restrictions. And they ended up like exporting all this stuff by printing out them in books, and because that was like one way to get around the export restrictions at the time. It was like really interesting stuff. So if you're interested in that, check it out.
I think this tiered access thing is super cool. So I've worked in the data-related healthcare industry in the past. In any regulated industry, for example, in healthcare, you have HIPAA compliance. Only certain healthcare professionals are allowed to see specific patient data. Not only they're not supposed to have access to it, but this component of OIDC that you mentioned, you need to know who accesses something, because if somebody inadvertently or incorrectly access the wrong information, all of that needs to leave a paper trail, right? So, but the question I have is, what happens if the provider servers go down in that case? Let's say you're working in a hospital and the servers go down.
Yeah, that's a good question. Obviously, if the Weaviate nodes are down, you can't access data. But one of the cool things about token-based systems is that once you have that token, you don't really need to access the token issuer servers all that often, right? So you need to issue it every so often when you want to first get the token, or when you need to reissue the token, because it is time limited a lot of the time, right, for security. But other than that, and also time when you want to pick up the public key for verifying the signatures. So other than those small windows of time, you're kind of fairly robust to that, which is really cool.
That's cool.
Nice. I was kind of thinking, like, because can you invalidate a token? Like, say, like, hey, I gave this token away before, but now I don't want to accept it anymore.
Yeah, so with auth, I think there's a few different ways of doing that. So a common situation is like you might issue a token, an authorization, auth token especially, to an employee, and then what happens if you terminate employment, or if they leave, whatever, right? So you can either there's ways of doing it. So a common way is like you get a token that expires fairly quickly, like in an hour or whatever number of hours. And then, but you get a renewal key or a renewal key, so you can use that to keep getting new token and the new renewal key. So you can turn off the tap at the server end to say that this renewal key will no longer work because they no longer work for us. So that's one way to do it. But again, it also means you only need to access that server like once every frequency of every time it expires. So again, you can achieve both things. Yeah.
Cool. Nice. So I guess, again, I think this is a pretty useful feature. I think one example where we internally at Semi using it, the tiered access to Weaviate, is actually how we build some of our public-facing demos. So, for example, like everybody probably know about this Wikipedia demo. So if you try to access that that instance of Weaviate without authentication, you can actually run queries, but you can't make any read or writes commands, which is really cool, because on one side we have the control of what data goes there. Like some people put like maybe they'll put some bad objects or something, and we can avoid that. We can make sure that the demo always is in a good shape. But then at the same time, anyone that wants to test it out and see like what sort of queries you can run on Wikipedia, they can access it. So I think that's also like one of the good approaches to do that.
Yeah.
So yeah. Nice. All right. So conscious of time, next we have leaving the best for last. So we have Zen. Zen, you like in the last release blog post, you were also covering an update to the backup functionality in Weaviate. So what's different? What's new? Tell us.
Yeah, this is one of the main flagship updates. It was super awesome to learn about this and talk to all the engineers, and the whole process of how the inner guts were revamped to provide this new functionality. Quickly stated, basically what it allows you to do is, before, you could back up your data as long as it was stored on one node, right? If all of your objects are stored on one node, that could be backed up. Right? Even if you had your objects or your classes multi-sharded, and what that means is, instead of storing one table, you take your rows of your table, and now you create, let's say you have a table of 4 rows, you can create 2 shards of it, where now that data exists as 2 tables but now both of 2 rows. Right? So you can multi-shard your data, and as long as you were doing that physically on one computer, you could still back it up. Right? That was 1.15. The new added functionality is that you can take these multi-shards, now you can distribute them across hundreds of different computers, and you could still back it up as if it all existed in one computer. Right? And that's a super cool feature because we can get into the many advantages of sharding if we want, but one of the things that I wanted to show you, if you could share my screen here. So kind of just hidden into the first demo was this idea of multi-sharding. What I did in that first demo was I spun up 2 nodes, and then I pushed data to those nodes, right? And here I didn't specify how the data was supposed to be stored, whether one class was supposed to be stored only on exclusively node 1, and then another class was exclusively stored on the second node. So this is a bit more of the functionality of the node API feature, but the data that you get back from that feature, you can actually tell that the data is multi-sharded. So if you look at your category class, you can see that 9 of the objects that I pushed are stored on node 1, and the other 10 so if you look at the category class here, the other 10 are stored on node 2. So this is what it means to have multiple shards for the same class, right? Same column, category column, but you have 10 rows that are stored in node 2 and 9 rows that are stored in node 1. And this is what a multi-shard, multi-node cluster looks like. Right? With 1.16, you can now back this system up entirely. Right? You could just call the backup functionality on this cluster, and it would be able to preserve all of your data. So in the event loss that we had, where node 2 went down, you could back it up and retrieve all the data immediately. Right? The one last thing that I'll add is that on the user interface side, nothing has changed, right? So you could still call the exact same APIs to back up the data. It's just that now you have the ability to back up multi-node, multi-sharded data.
Nice. So can I then, if I have a backup created with version 1.15, can I restore it into 1.16 instance as well?
Exactly. It's perfectly backwards compatible.
So that could be a cool way to migrate to a newer version of Weaviate.
Yeah, for sure.
Huh. Didn't think about it before. That's actually a fresh one.
Is it correct the understanding that, like, as we have like billion scale tests, that you could have this multi-node backup and then you could just restore it to instantly have like a billion scale vector data set, just restore it and then you're running with it?
Yeah, exactly. If you have the compute and the hardware to be able to support it, then you could definitely back it up, right? And that's the whole the scalability component of this thing. You could have hundreds of computers where your data is distributed across those hundreds of computers, and if, let's say, 20 of them go down, you have a backup for the entire thing, and you could restore those, right? As long as you restore the physical hardware, then you're good to go.
That was going to be my question. Like, what happens if a few of the computers go down? Like, what happens with the nodes that are on there?
Yeah, so the nodes that are present will still be able to, you'll still be able to back those up, but until those, so you'll have a previous backup that you had when the nodes were up. Right? So if you restore the hardware, you can recreate those 20 nodes, but you could also actually create a backup of the 80 computers that are still remaining.
Got it.
Yeah.
Really cool.
I think it's just amazing, like how long it would take you to, say, vectorize like a billion passages you scrape from the internet. Now you no longer would have to wait for the import times. You can just restart it and then you're running with it. Amazing.
Yeah. I'm kind of, yeah, because like since you explained, like my mind is going like all possible scenarios, because Connor, you mentioned the billion data scale and everything. But like, what if you had a setup where, let's say, you were perfectly fine, like you had 200 million objects, your environment was set up just right, but then you realize that like your data is growing really fast, and then suddenly, like maybe you need more nodes or maybe you need different servers. So I guess this could be pretty cool because we could create a backup, spin up more instances or more powerful instances, and then kind of restore. And then now you could grow from, let's say, 200 million to like the next level that you anticipate for, right?
Yeah, Exactly. The great thing about distributing your data across multiple computers is that it's super scalable, right? Not only are the queries scalable because now per computer you have less data. You're not storing all of your data on one computer. Your queries don't need to filter through as many data points before it can come up with an answer. But if tomorrow you get much more data, you can always expand, go from 100 computers to 200 computers, and you have literally infinite scalability. Right?
Nice. That's cool. All right. So you showed us a demo before with like 2 nodes. I'm going to be trying with like 20 now. Let's see what happens. But I promise I won't kill any of them. I won't harm them on purpose.
Yeah, that's my job.
That's your job. Yeah, I'll call you over for that. All right. Thanks then for this update. It was actually super exciting. Isn't it cool that like you talk about backups and many people would find it like not so exciting and boring, and then Zen comes in and there's like this whole conversation coming up. Like, Zen, you have a special talent. You make even backups sound exciting. So that's pretty cool. All right. So this concludes the part of the Weaviate features and updates. Like I mentioned at the beginning of the stream, we are already on Weaviate 1.16.1. So I definitely recommend you all to upgrade to it, like especially if you want to take advantage of all the cool features that the team here just described. It's definitely worth it. We are super excited, really proud about it. But if you have other ideas, other suggestions on what should go into Weaviate, or if you have any feedback, or if you just want to share some love, in terms of, because there's been a lot of work that went into it. We're more than happy. Join us on Slack or drop us a message even here. We monitor the messages on YouTube and we can see them as they come in. So that's great. And I want to basically finish with a Connor's segment where he will cover like what's new in AI in October. And I know, like, Connor, you read like so many papers every month in research for cool things that could go into Weaviate. So what do you have for us?
Yeah, cool. Well, let me tell you about some of the things that I thought were cool this month. And so first, the full screen is good. Is sharing it?
Yes, we can see Weaviate Air too, Connor. Short.
Okay, cool. So with the ref2vec thing, I might have been a little hand wavy with the graph neural network thing. So in this slide, I promise you will understand what a graph neural network is. And starting with this new paper from Amazon Science recommending related products using graph neural networks in directed graphs. The core thing with the directed graphs is that there's an asymmetry in recommendation. You buy an iPhone, you need AirPods, you need a phone case, but usually when you buy a phone case, you don't also need AirPods. So they have two separate kinds of relations in the graph. So in Weaviate, so we have a phone case, phone is one kind of class, or it's all product. We still have different named relations within the class. So you could have, co-purchase relationship, co-viewed with cross-reference relationship in Weaviate. And so they have this graph where you have co-viewed, which are these bidirectional lines, and you have co-purchase with, which are directional lines. And really what I want to do with this is explain what the graph neural network is. So the core idea with a graph neural network is it has a message passing prior. So when you have, and the core idea with this new idea from Amazon Science is that you have two embeddings for each node. So A has a source embedding and a target embedding, and sources like from network science where it flows from the source A to C and to B, but A doesn't flow to D; it's a target to D. So the idea is you have two separate embeddings for each of these things. So let's get the math, and I promise you'll understand what a graph neural network is after this. So graph neural network, similar to deep neural networks, it has L layers. So let's just 8, 12, whatever amount of layers. So you initialize it with some features for each node. So usually say you have a text description of the product, bang, vectorize it with mini LM. Now you have a 384 dimensional vector at layer 0 of the network that represents, say, this iPhone case. So now what we're doing is we have two edge graphs, this subscript CP and subscript CV. So what we do is we're going to do the message passing by averaging out the vectors that this source node is connected to. So again, with this example of A is connected, it goes to C and B. So at each layer of the graph neural network, we average the vector of C with the vector of B, and then we multiply it by that layer's weight matrix. So say it's 384. the average will be 1 by 384 times 384 by whatever hidden dimension we want to do with that layer. So let's say it's 512, and then you end up with a 512 dimensional vector. You can like blow up and shrink the kind of latent bottleneck that way, however you want to do it. So in the end, you end up with, and you do this is all differentiable with the weight matrix. So you learn this weight matrix. And in the end, what you're doing is you're producing embeddings for the nodes. And the embeddings for the nodes are how you then do recommendations. So you want to recommend a target from the source, you query with the source node, and you learn that node embedding through the several layers of these graph neural networks. And you do that with this loss function where, the co-purchase things, you try to make these similar to, the iPhone source, going to the iPhone case, the target, and make that dissimilar from a randomly sampled one. So let's say there was also like a set of dumbbells also as a sample target that was also on this like Amazon product graph. So then you also have, making source representations similar to each other in the co-view relations, if you know these subscript. And so that's how it works. So quickly before moving on, because I think this is the most important like technical concept, does everyone feel good about what a graph neural network is?
Are you stacking the, so you mentioned that you have multiple nodes and then you're learning the weights. Are they stacked on top of each other? Is that how the layers work?
Exactly. So at layer 0, you have the initial sentence transformer vector for C and B, and then so A will be the average of those two. Boom, then you multiply by the weight matrix, and you did that also for C with its E and F neighbors from source, and then now we're on layer 1, and so on. So you just keep doing that.
Okay, I see.
Cool. So awesome. I hope you all thought that was interesting, and thanks for that, Zen. So some other things I thought were really cool and related to RefDivec was Pinterest posted this blog about how they use that RefDivec centroids kind of idea for their home feed and their recommended pins example. So they start off by, say you have 80% of the time you're on Pinterest, you're looking at interior kitchen designs, 15%, let's say birthday cards, and 5% pictures of dogs. Previously, what they had is then when they're doing the home feed, they just sample 80%, 15%, 5% with the recommendations. So now they've added this bandit style feedback loop where what you click on. So, say you start clicking on the dogs, it'll increase the sampling rate from that rather than just the static sum of actions. Because say, you used to be on Pinterest and you looked at like 2,000 images of interior kitchens, and then now your recommendation is so biased by your past behavior. So this feedback loop would be one way to update it in addition to this kind of interaction window idea. So next I want to talk about re-ranking, and I thought this paper was a super cool idea. So to start off, re-ranking is about we retrieve some documents and vector index returns us a ranked list by vector indexes, but then we'll hit it by like a pairwise classifier to get even better rankings for the results. And so what the core insight is, the performance of a re-ranking pipeline is limited by the recall of the candidate pool. However, this is because documents that were not found by the initial ranking function have no chance of being re-ranked. And I think this one, so the idea is you retrieve, say, 100 documents, re-rank, and then you have the top 10, and now you use the top 10 as query to get, say, another 10, and then blow it back up to 100. So I think this is a little counterintuitive at first. You might think like, okay, the nearest neighbors to the query, aren't they the nearest neighbors to each other? But they're actually not because of this high dimensional space. So, the nearest neighbors to the query, document 1, 2, 3, 4, 5. The nearest neighbors to document 1 might be like document 7, document 13, and then documents not even in the list, like 81 or whatever. So you expand the list, and then you have more candidates to re-rank. And it's a really neat heuristic that improves the results on a lot of these techniques like BM25, Dr. Query, Colbert, and Splade. Cool. So the next idea is another re-ranking strategy that I thought was really interesting and different from kind of just the binary classification query document, put it to a binary relevance label. This is the idea of using language models to score the likelihood of the input question conditioned on a retrieved passage. So you train your language model by concatenating your data set of document and query, and language models just predict the masked out token. But the way that a language model predicts the masked out token is by assigning a probability to each of the next words. So say the sequence, we estimate log P of Q given Z sub I using a pre-trained mask. It puts, say, 85% on language, and then it has this massive distribution of probabilities on all sorts of other words. So what you're doing is you're going to multiply out the probabilities of the query as you say, have the document, and then you go mask, 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 and you're putting in the probability of the of the passages that you've retrieved. And you can use this to re-rank the passages based on the probabilities of their likelihood coming out of the language model. So I thought that was another cool idea. And they show how this improves over the contriever, the DPR model, compared to this idea with the re-ranking the contriever with the language model. So another kind of cool idea like this idea of, maybe taking the passages input and then outputting the query and inverting the process is this paper, Decoding a Neural Retriever's Latent Space for Query Suggestion. We learn a query decoder that, given a latent representation, generates the corresponding query. So you have some kind of gold paragraph like this Illinois election 2018, a general election will be held, whatever. So you then hit it with a sentence transformer, and now you have the vector, and now you decode from the vector the query that would match with that paragraph. So it's not an obvious thing that, say in BM25 search, you have pseudo relevance feedback where you know how much weight you could put on the keywords to have matched the paragraph, but it's not so easy to invert the space in the neural space where you have to generate it into a natural language query like this. So I'm not sure yet what this is useful for. They have ideas like you traverse the latent space from the original query and try to have like an ensembling of nearby queries that are similar to this latent space. But generally, I think it could just be an idea that helps you get a sense of what's going on with your models as you upload documents and it says queries that would match with it. Maybe it gives you some insight into how to query it.
Maybe we could use this for generating queries for Jeopardy, right? So if you have an answer, it's like, hey, find me the question that will go well with that. And then, so you could have like a vector search engine Jeopardy, you could have few instances of Weaviate. Maybe Zen can set them up on distributed nodes, and then each of them can ask the right question.
Yeah, exactly. We're making the language models play Jeopardy and answer what was the question rather than the answer.
Hey, what can go wrong, right?
Yeah. Cool. So the next topic I want to get into is an update with Gina AI's fine tuner. So there's a very interesting space in model training software. We have like Keras, TensorFlow, PyTorch for training our models, and that requires a bit of knowing how to get the data loader, how to get the optimization loop, define the model architecture code. And Gina AI's fine tuner has created this way of pipelining the document array, which is where you put your query document labeled examples, particularly for multimodal image text captions. And accessing a lot of these features use the train clip, like the WISE FT, robustness trick. There's a lot of things that are built into the fine tuner. And so here's some results that they presented shared in their blog post about the updates with this. Flickr 8K 8,000, 32,000, 200,000, and bang, massive improvement from the 8K in retrieval. So you have a text caption, you're searching for an image, and if you have some kind of really particular data set, I think this kind of domain adaptation achieved through fine tuning, model training software that makes this easy, I think it's incredibly exciting. And then we see more modest improvements on Flickr 30K and MS Coco. So this is building on the CLIP baseline, which is a pretty general model, but I think this is super exciting for domain adaptation in general. So now we have some.
Hey, Connor, before you jump to the next one, we actually had an interesting question from Etienne. It sounds like there's some plus ones also on building the idea of Jeopardy with an AI-based engine. So hey, you maybe you spoke too soon that you didn't know how to use it. We might have just came up with, what to do.
Yeah, I got something I have to do. Cool. Awesome. Okay, so keeping it rolling now. So now we're kind of pivoting into more things that aren't as particular to search, but in this general space of large language models. So Google is back at it with another amazing language model. They've already trained 540 billion parameter, this PaLM model, 3 times the parameter count of GPT-3. And now what they're doing is they're training this model with instruction fine-tuned tasks. And I mean, plus 9.4% on average, massive multitask, just unreal ability for a large language model. So let's kind of start about like, what is instruction? So this kind of it's like this chain of thought thing. Well, actually, let me start the story with T5. So before the T5 transformer, people would use totally different architectures for different natural language processing tasks, like natural language inference, question answering, text classification. They would all, have a different way of compressing it into a classification layer. Then T5 said, how about we just language model this? Let's just, as the prefix, say question answering, then give it the input, and then mask, and then the mask will be the answer, or The mask would be yes or no for binary classification, and so on. So you unify all language tasks into language modeling. And now they have all sorts of ways of mapping tasks into the description of the task. So, obviously with GPT-3 in context few-shot learning, you give it input-output examples with some description of the task as well. And so instruction fine-tuning is kind of similar. They also have that with give the rationale before answering. So not only answer it, but explain yourself, and then chain of thought fine-tuning, which is this is how you would explain yourself. So if it's something like, I had 23 apples, I gave you 20, you say, okay, I had 23 minus 20, I have 3, stuff like this. So what they did is they have this just incredible diversity of tasks that they've fine-tuned this one model with, and it's obviously a massive model. So the next super interesting thing in large language models is large language models can self-improve, and this is the same idea as this chain of thought thing. So again, with chain of thought, the question is, Stefan goes to a restaurant with his family. They order an appetizer that costs $10 and 4 entrees that are $20 each. If they tip 20% of the total, what is the total amount of money that they spend? So what you do with chain of thought is you break up that question. You say, okay, the appetizer costs $10, the entrees cost $20 each, so 4 times 20, and so on. So the way that language models work again, and this comes back to the Jeopardy thing and say using this to do re-ranking, is as it's doing this output, it has a probability for each of these words. So the is say 75%, appetizer is 60% of the next step, cost is 90%. And so you can do different decoding paths through large language models in general. So say greedy decoding is you just take the maximum probability at each step. You can have beam search, all these kind of things for decoding pathways through the output. So this idea of self-improving means at the end, the model might, it takes different paths to get there. You see how 90 times 1.2 compared to 90 plus 18, but in the end, they have the same answer. So this consistency is used to filter the outputs and then use this as additional training data for the language model. So output 1 and output 3 are then concatenated to this question, and then the language model does some additional training by language modeling that. Another incredible idea for further improving the performance of these language models. Okay, so then just another thing that I find this research in iterative writing to be extremely interesting. So I quickly want to present this idea as well, where instead of, again, just having a language model, say, greedily decode a story, you have this iterative plan, draft, rewrite, and edit. And I think it's really interesting how they break this down into plan. It generates a setting giving a premise. It generates characters. They have this kind of knowledge graph extraction for factual consistency within the story. Start writing the story, and then you have the rewrite where you have this coherence and relevance ranking. So this is kind of a part where this whole ranking search pipeline thing comes in to filtering the potential decodings of the language model, ensuring factual consistency. And overall, I just think it's an incredibly interesting idea for generating long stories with language models. So then let's talk about the other way of doing language modeling. These 3 ideas are these, massive language models. You put 100 billion parameters, you just compress all the data into the parameters of the language model, compared to retrieval augmented language modeling, where you have the query, you have the input, use that as a query to retrieve some information, and then you condition your generation on that retrieved information. So in the last Weaviate Air episode, we talked about Facebook AI's Atlas model. And particularly what they're doing is they're seeing, can those retrieval augmented language models also achieve few-shot learning, where you give it a few examples and it learns a task, because that's one of the core cells of these large language models. Now we're exploring, can they do common sense reasoning? So the problem with common sense reasoning is it's a different kind of retrieval task. So the question is, only after learning you can gain knowledge, these little common sense things. And the question was really can the retrieval generate relevant things or what? The next thing is using this kind of retrieval augmented strategy for multimodal information. I think this is also extremely interesting. So you have questions like, what shape is the pediment used by Capitol Hill in DC? And so you need to kind of retrieve this image, and then you look at it and you go, triangular shaped pediment. The way they do this is they use the embeddings of images and the embeddings of text. They put that into the same document index, and then fusion in decoder style, retrieve and read, generate answers, train it with these VQA data sets. Okay, and then finally, the last thing is the massive text embedding benchmark, and it's about having universal text embeddings applicable to a wide variety of tasks. We love using it for retrieval. We think about this a lot. You say fact verification, you have a claim, can you retrieve the evidence for this claim? We can also use embeddings for, say, summarization where you have the similarity score of the embeddings between the long document and the potential summaries. You could have a pair of sequences that you compare the embeddings to do some kind of classification with, and all sorts of things like by-text mining. Say you use embeddings for translation you say something in English, embed it in English, nearest neighbor in the French index, that's going to be the translation. So it's a collection of a ton of different tasks, a ton of different data sets, a ton of different languages as well. So a really interesting way of seeing all the things we can do with embedding-based models. And then, it puts a scale for comparing GTR with MPNet, with our mini LM, with Spectre, not our, like we developed it at Weaviate, but this is just a common sentence transformer, lightweight, use it a lot. Spectre, BERT, a lot of these things on the same scale. So thank you so much for listening to this. Please let us know anything you thought was interesting, and I hope you check out Weaviate to learn more about the Weaviate vector search engine.
Excellent. Thank you for this huge overview, Connor. That was really good. And basically, just for everyone in the audience to know how important this segment was to Connor, he literally has a taxi about to arrive in half an hour. So, he was still in this. He's still in this. Like, yeah, I can still make it on plane and fly over to Italy, because like a bunch of us, like pretty much everyone in the company, most of the people in the company going to meet in Italy soon. So yeah, thanks Connor for taking the time. I know you're going to share some of the materials as well, right?
Sorry. Yes.
Yeah, go on.
A Twitter thread that has the links to each of the papers, if that's what you're looking for. And yeah, I think we'll continue thinking about how we want to share this, if we want to write something or something, but hopefully just the links is enough for now.
What's your Twitter handle, Connor?
C_30. I'll put it in the YouTube chat.
Yeah, let's do that. So yes, if any of you wants to actually get the list of everything that Connor covered, you should definitely follow him on Twitter. And without a say, you should follow each of us as well. But I would definitely say follow Semi Twitter handle and Weaviate as well. So I think that's pretty much it from us. This is all we had to cover for today. Thank you all for listening. Thank you for my co-host. You all did an amazing job. Any final words, anyone?
Thanks for listening, everybody.
Thank you.
Thank you.
Thanks a lot. So let's do a collective wave, and then I'm going to stop. Thank you. Bye.
Bye. See you next time.
Bye. Sergey says bye too. Bye.
Bye, everyone.
Bye.